Okay, let's start. So for today, we're going to talk about Agile team, pretty much looking at this Agile practice from the team perspective and also the procedure and the workflow. So there's also some good practices around how to set up an Agile team, how do people work together, how the day-to-day procedure looks like. So that will be our focus for today. I kind of have to try to condense that content in one day, because I realize our time is still limited, given the remaining only 2-3 weeks for this course, and also we will have a holiday break this Thursday. So which means, so yeah, talking about Thursday though, because it's holiday, so we won't have course that day, which means we won't have live stream, but I still kind of have to put some content up there, make sure we can finish everything we want to talk about for this course. So I will record it on Thursday and then put the link in the chat room as well as in the online classroom. So yeah, that's for Thursday. So going back, so today, after our discussion with legacy code and refactoring, so pretty much everything so far is about writing code, and then the development of a application. And then today we kind of shift the focus a bit to talk about the team, the people, the procedure, the workflow. So so we won't have really a practice on that, because again, everybody locates everywhere, so it's kind of hard to have everybody to form a team and do a project like that. So for today's lecture, we won't actually have a chance to practice it, but hopefully, during some training program, or maybe some ministry you will serve, hopefully you get a chance to work with a team of developer and either already have established practices and then you can try it out there, or even on some side projects to team up with other developers, and you can also try it that way. So yeah, but anyways, since we don't have time, we don't have the chance to practice this part of thing, so we will just go through the concepts and hopefully you can see the point, even remember some of these important stuff, and hopefully it can help you down the line in your career. Alright, so without further ado, let's get into the video today.
There's no question that software engineering is now a team activity. Modern software is just too complex for a single person to develop by themselves. So being a good software engineer isn't just about having good technical skills. It's knowing how to use those skills effectively when you work as part of a team. These processes combine effort estimation techniques like points and velocity with quick and frequent meetings of different kinds to keep the whole team on the same page as to what's going on. An iteration planning meeting lets the team reach agreement on the likely effort for each user story and divide up the work. You've probably already used a version control system like Git to manage your code, but in this module, you'll learn how teams can use features like branches to work in parallel on different stories without stepping on each other's toes, and how the merging of each code contribution into the main code base represents an opportunity for a code review. Yes, developers are responsible for building and testing their code using BDD and TDD, but code that is correct but difficult to understand and maintain is a technical debt that the team is taking on. Frequent code reviews as part of the code merging process prevent ugly code from becoming part of the final product. And each contribution, when merged, can automatically trigger a run of all of the app's tests in a continuous integration, or CI, environment, so the team knows immediately if a new contribution has caused existing code to break. During this whole process, daily scrums or stand-up meetings make sure that the whole team knows if any developer or if any pair of developers is facing an unexpected obstacle that puts the original effort estimates in jeopardy. And since Agile is about embracing change, each iteration ends with a retrospective meeting discussing what went well and what could have gone better, so that subsequent iterations can learn from the mistakes of the past. An effective Agile team is one in which these processes run like a well-oiled machine. The team gets into a steady rhythm of estimating user story points, using BDD and TDD to work individually or in pairs to deliver those stories, reviewing each contribution as it's merged, and constantly asking how they could do even better on the next iteration. Turing Award winner Fred Brooks Jr. liked to quote Dean Smith, the coach of the men's basketball team at the University of North Carolina. He used to say, "There are no winners on a losing team and no losers on a winning team." Being a valuable software engineer means bringing your talents to bear not only in your own individual work, but as part of your contributions to a smoothly running team. The tools and processes in this module reflect up-to-date best practices in the Agile community for doing exactly that.
All right, so that's the quick overview of the content today. We'll go straight to the next video.
Talking about teams, I think that the real thing that changed in software sort of over the course of my career is that there was a time when you could realistically expect that a single individual, or maybe a couple of individuals, would be solely responsible for producing some genius piece of software, and those times are long gone. I actually went and looked up sort of 3 or 4 landmark video games that were considered sort of groundbreaking at the time they came out. And you know, the 80s were sort of the last time that a single person really was in charge of a software project kind of all by themselves. So software engineering is pretty much a team sport. Any interesting project now is a team project. And that means that to have a successful software career, it's not enough to have good programming skills. You also have to be the kind of person that works effectively with others and that makes your entire team successful. Because one of my favorite team-based quotes from Turing Award winner Fred Brooks is that there are no winners on a losing team and there's no losers on a winning team. You know, it's really an industry where if the team does well, that's good for everybody on the team, and if the team does poorly, it doesn't really matter if there were sort of a couple of people who thought that maybe they were superstars. So as I've said a couple of times, and I've shown even from your previous colleagues who have taken this class, one of the biggest pieces of advice that they said they would give to students in 169 is to have as frequent and sort of as close team communication as you possibly can. And we've been recommending that, you know, if it's possible to touch base even every day in a small scrum, just a few minutes to keep everybody on the page. If you've also heard the term stand-up, some people use the term somewhat interchangeably. They're technically not interchangeable, but stand-up is intended to connote that this is not sort of a formal sit-down meeting. It's short enough that conducting the meeting while standing up should not be a burden, so kind of 5 to 15 minutes. And the basic protocol is you go around for everybody in your team and you ask, each person answers 3 questions. What have you done since yesterday? What are you planning on doing next? And what is getting in your way? What is blocking you from the next things you want to do? Sometimes what's blocking you could be that you need to work on a feature and use a mechanism that you're not familiar with, or a library that you're not familiar with. So sometimes it's sort of technical knowledge, things that you have to do. In some cases, other people on the team might say, oh, actually, I have some experience with that library. Let's take 10 minutes and I'll sort of give you a brain dump of do's and don'ts. And sometimes the blockers are things related to the team. Like, I need to add a migration to do X, but I can't do it until somebody else finishes their migration. Or I really wanted to add some foreign keys to establish this new relationship, but I wasn't sure if it was OK to change the database schema. Is there anybody that would, whose work would be really messed up if I committed a change to the database schema? So bringing these things out in the open on a regular basis, sometimes they can be resolved on the spot, and then the blockages go away, and everybody can keep their work going. So when you have these meetings, there's a couple of well-defined roles, some of which you already know. For those of you who don't know the term two-pizza team, it was theoretically, I think it was coined by Jeff Bezos of Amazon. The number of people that 2 pizzas can feed is about the right size for a team. That if it gets larger than that, it's sort of too hard to coordinate, and it's worth trying to split the project down to see if you can have separate projects working in parallel with smaller teams. So one role you already know about because of BDD is the product owner. So when the customer is not actually in the room, the product owner is trying to represent the voice of the customer. We can, I guess, think of them as the customer's advocate. What would the customer say? If we're talking about during the meeting reprioritizing stories, or if we're talking about making a change relative to the stories and diagrams that came out of a customer meeting, what do we think the customer would say about that? And as we know from the BDD stuff, that's also usually the person who is responsible for leading the prioritization of stories for that iteration. Our recommendation for pedagogical purposes is that you rotate this role so that a different person gets to do it on each iteration. With a 6-person team, not everybody will get to do it, but at least if 4 people out of 6 get the opportunity. The other important Scrum role, which is a different person, is the Scrum Master. And if the product owner is the customer's advocate, the Scrum Master is the team's advocate. And this person's job is to essentially make sure that things that could distract or impede the team's progress are getting taken care of, and the team sort of doesn't have to deal with them. So in a corporate environment or a software team environment, sometimes these things have to do with, there's a meeting scheduled that maybe is not essential for my team. Maybe I can go to the meeting and represent the team so that they can keep getting work done. Maybe it's that there's a particular person on the team who is also sort of like acknowledged as an expert on some topic, and people tend to interrupt that person all the time and bug them, and the Scrum Master's job might be to sort of protect that person's time. Sometimes, even in a course like this, if you have an unresponsive customer, or if the product owner hasn't been responding, the Scrum Master can push back and say, hey, I'm responsible for the well-being of the team and keeping the team on track. We need you to be more proactive in telling us what the customer wants. If there are team members who aren't contributing, or team members who seem like they're distracted, sort of keeping the team on track. If the team has rules about, for example, how you do pairing, the Scrum Master can help make sure that those rules and protocols are being enforced. So in general, anything that would prevent the team from making progress, anything that is and in particular non-technical things that could get in the team's way. In industry, this is more often somebody who has the role for a stretch of time. But again, for the purposes of learning, we would encourage you to try rotating this role during each iteration. We aren't sort of going to police that you do it equally, but we will probably ask you who has been the Scrum Master and the product owner. And I think trying to be in the position where you manage a small team is really valuable. One of the things that both, really everybody in the team, but the Scrum Master oversees is what is the best technical approach or architecture or implementation for a certain thing. And then how do you resolve conflicts like that? Because I think you have to begin with the assumption that you really are all on the same team. Everybody wants the software to be successful. So everybody is arguing for a particular point of view because they think that's really the best thing for the project. So the first thing to do is actually enumerate the things that the two sides agree on. Where is sort of the first point that they diverge? And you may find that, in fact, the differences between the opposing viewpoints are maybe not as serious as you think. And then, just to make sure, have each side articulate what they think the opposing side's position is. Because often conflicts really come from a lack of understanding or about assumptions that might be incorrect about what the other side believes. So sometimes just sort of getting the information on the table and making sure that each side really thoroughly understands the other's argument. And then assuming that, in fact, there is a difference of opinion, where do you go from there? At Intel, we learned a term called constructive confrontation. And their culture is really kind of built around this. The idea is that anybody who has a strong technical opinion and they think it's best for the project if they were doing it a different way, it's sort of, it's part of their job is to bring that up. It's okay to confront your peers and your boss, but the confrontation is not personal. It's about two people having a technical disagreement. A technique that I recently learned about, which sometimes is used to help resolve this, is what's called the Fist of Five, which sounds like a martial arts movie or something. But basically what it means is kind of like in planning poker, where one of the ways people do planning poker is you can sort of do this like rock, paper, scissors, and everybody votes on how many points they think a story is worth. When you have a disagreement and then somebody proposes a way out, like proposes a path forward, you can have everybody vote with 1 through 5 fingers, where 5 fingers means that's good with me, I'm totally on board, I think that's the right thing to do. And 1 finger means I think you're going to tank the project by doing this. And the idea is that if you have people who are voting sort of 1 or 2 fingers, even if it's a minority of the team or just one person, that should be a reason to try to discuss a little further and come to some consensus. There are times when the right technical approach could benefit from an outsider perspective. Your GSIs can help. I may be able to help on things like this. Sometimes it's really a matter of if one of us has experience having done something similar, maybe we have some piece of information we can contribute. But the important thing is to get to a point where maybe not everybody on the team is 100% on board, but you've decided on a way forward and nobody is saying, all right, over my dead body is this going to happen. Once you get to that point, and this is another Intelism, it's disagree and commit. Right? It's not disagree but commit, because that implies that you're sort of keeping your mouth shut about it. Disagree and commit is you're making clear, I don't agree, I still don't think this is the best way forward, but we've discussed it, this is what the team has decided to do. I will now contribute in any way possible towards making this approach as successful as it can be. Right? So there was a great article about a year ago in Communications of the ACM. Don't think of conflict resolution in a team meeting as who's going to win the argument. It's winning the argument is not the point. Resolving the situation is the point, right? It's kind of like it's the whole team against a technical problem. It's not one faction of the team against another faction. So keep reminding yourselves that you're literally and also figuratively on the same team in trying to get through these disagreements. And everybody's trying to bring their best ideas to the table. You can argue against an idea, but you don't argue against the person, right? I disagree with your idea because is actually subtly different than I disagree with you because. The idea and the problem that it's trying to solve are the thing that you want to keep front and center, right? So that at the end of the day, you can all still go out and have dinner together or something. As I mentioned before, with the super bright yellow slide, the previous feedback is that having even just a 5-minute daily stand-up, which can even occur on Google Hangouts if you're not all in the same place at the same time, but having just a quick check-in so that if there's any surprises about what people are working on or blocked on, you can get them out of the way pretty quickly. The teams that didn't feel like they communicated enough felt that that really hurt their project. It made it hard to coordinate their work. Certainly the teams that had the strategy of, we're going to have like 1 meeting a week, kind of like you have 1 section a week, definitely not enough. And as you get further into the project, I think these things become more and more true. And the teams that didn't sort of designate a person to run each stand-up kind of wish that they had. In fact, you could actually do this if you're meeting multiple times a week, as I really hope you'll get to the point of doing, is you could rotate the position on each one of the weekly meetings, not just on each iteration. And then everybody actually will have a chance to do it. Okay, so learning to work together this is actually one of the most important skills that software companies look for, I think. Best practices around doing team coordination with Git. So as you do release branches, feature branches, what are the kinds of things that can go wrong, and how might you try to avoid some of those things? I think if I had to summarize, do work in small chunks. Commit early and commit often. And when you're working on a branch, in some sense, your goal is to get off of that branch as soon as you can. Right? Get back to the point where your branch can be rebased, merge back into master, and then get on with your life. There's much better Git cheat sheets out there, but there's a number of things that have to do with undoing things that went wrong. Different forms of Git reset to make the world look the way it was before a botched merge or before a botched rebase. I put them in red because Git reset -- hard is one of the very, very, very few things you can do with Git that actually destroys code. If you're committing early and often, it's very unlikely that any code you write will ever just vanish off the face of the earth. It may take a little work to find it, but you're like, oh gosh, I remember I had done that, and it worked, and I can't remember what I changed. The code is there somewhere if you've been committing frequently. But the one thing that you can do that actually loses information irretrievably is Git reset -- hard. So use with extreme, extreme care. There's many different ways to do the diffs between files. The standard one that you see is if you have the name of a branch or even a commit ID, you can say, relative to where I am right now and how the file looked at that commit or that branch, show me the diffs in specific files. You can also do things like this, which are really useful. Like, show me what the difference between my file is right now and how that file looked on the master branch on this date. So this is of the form, on Tuesday this was working. OK, well, figure out whatever date Tuesday was, and you can actually see the specific differences in whatever the most recent commit was as of that date. You can even say things like, at 2 days ago, if you've been up for 2 days and you can't see straight anymore. You can temporarily show what a file looks like in some other branch without having to switch to that branch. So if you're like, oh, I'm working on a branch, and I'm trying to remember what it was I was fixing, you can actually just temporarily output a copy of the file as it appears in that other branch. And of course, you can ask, with git blame, you can ask, who were the last people to modify each of these lines of this file? Like, damn it, somebody broke this file, and I want to know who to point the finger at. It's kind of a funny named command. But remember, you're all on the same team. Mistakes will be made. You might do something like making the person who appears next to git blame like eat a disgusting candy or something, but keep it collegial, right? Everybody makes mistakes. You're all here to learn. And of course, Git Log, super useful because every branch has its own commit history. So when you're on a branch, what you want to know is, on this branch, what's happened to this file, as opposed to what's happened to this file on its whole life, no matter which branch it was on. So Git Log will show you the commits in order, in reverse order for the file just on that branch. Git is, I call it the Swiss Army chainsaw of version control systems. It does everything, and it can be really intimidating. So expect to spend some time Googling, how do I do X with Git? Git can certainly do it, and sometimes the command line options are obscure, but it is there. And ask us if you need help and stuff like that. But Git is a power tool, and as long as you're careful about reset -- hard, commit early and often, and every piece of code you ever write at least will, you won't lose it. OK, so that's kind of my sort of golden rule. Pitfalls. This one is less of an issue with some IDEs, but here's a scenario. I'm working on some branch. I have some file open in my editor. Now I decide that I need to temporarily switch to another branch to look something up. I temporarily switch to that other branch in my terminal window, but that actually causes Git to modify the file system under you when you switch branches. So now the file that's still sitting in my editor actually has nowhere interesting to be. If I save that file, I'm going to stomp on the version in the branch I just switched to, which is probably not what I want. Now, there are a number of IDEs, like the cloud-based ones, and I think RubyMine, where the editor is sort of Git aware. And if you switch to another branch in the terminal, your editor will do something sensible. Like it'll say, do you want me to switch to the version of this file in the other branch? Or before switching branches, do you want me to save the current version of the file? But just be aware, if you're not using an editor, an IDE that knows about Git branches, this is a possibility. In general, before you pull or merge, make sure that you've committed. Commit early and often. And after you pull or merge, just reload the files into your editor and make sure that the editor is aware that you're on a new branch. Or quit the editor before you do your commits. Say what? OK. Letting your local copy of the repo get too far out of sync. So git push and git pull, you should be doing them all the time, right? Remember that the GitHub copy of the repo and your copy of the repo are both complete copies of the repo. So anytime changes are being made on one, they should be propagated to the other as soon as you can, because otherwise, when it's time to do merges, they will be painful. I make it a habit that when I sit down to write code, I immediately do a git fetch or git pull before I start to make sure I have the latest version of what's in the origin repo. As soon as I reasonably can, I'll do a push, even if it just means I'm pushing my own branch, right? Because that way, at least the fact that I'm working on that branch gets committed to the repo, and my team would know about it. I was going to say, if you have a long-lived branch, rebase as often as you can. But the truth is, you shouldn't have long-lived branches. We'll talk about this next. But if you're doing branch per feature, the feature should be small. If your branch is living for more than like a day or two, you're asking for trouble. So we'll come back to that in a moment. I think it's a fallacy to say, oh, this is a simple change, just do it on master. Programmers are optimists. We always think every change is a simple change, and we're usually wrong. We're like, oh, this is a one-line change. but then you change that one line and you realize that that ripples and it's going to affect another line somewhere in the file. And now you have to change a test because the test doesn't quite work the same way anymore. And pretty soon you've like left your paw prints all over various files on master. And that violates the invariant of master should always be safe to deploy from. So the solution to this is simple. Always do a feature branch. And by the way, a bug fix is a kind of feature. So a bug fix branch and a feature branch, kind of the same thing. Branching is basically free. And if you were really correct that it's a one-line change, you won't be. But if you were, you can delete the branch right after merging, and it's like nothing ever happened, right? You don't even push that branch to the origin repo, and like the world doesn't even know the branch existed, but you maintain the invariant that master is always uncontaminated and clean right up until the moment that your pull request with your nicely rebased, everything is passing branch makes it into the repo. Organize your work. We really recommend that you work from a single repo, not from every developer having their own fork, for the reasons I said before. When you run into problems, I think you know some of my favorite strategies. Let me Google that for you is probably the strategy that I use most. Writing an effective Stack Overflow post, or a Piazza post for that matter. We had these guidelines at the beginning of the semester of really read the error message carefully. Like, it's still surprising how many posts you see where it says, I have no idea what's wrong. And the error message says something like, file X in directory Y is missing and should be there. Or expected file X to define class Y, but it did not. If you read it and just sort of take it literally, you can get really, really far. And when you're composing that post, sometimes the act of composing the post will actually reveal the answer to you. You're like, oh, right, of course, that's what happened. So don't underestimate. High-functioning, streamlined development environment. What do I mean by that? It means that when you sit down to code, there's a ritual that involves typing at most 1 or 2 lines, and then you're ready to go. So in my case, I open my terminal window, I change it to the right directory, I make sure that my database is running, because for complex reasons I have to develop against Postgres, and I switch RVM to use the correct version of Ruby, because I have several different projects that use different versions. That's it. Once I have done those 2 things in my terminal window, the environment is in a predictable state. If you have to do a lot of manual tweaking just to get started on coding, ask yourself what you could be automating. Is it something that is just specific to you? Is it something that your whole team could benefit from? But as much as you can, automate away things that are multiple steps, because you just are increasing the risk that you'll manually not get the steps right. And then something won't work the way it normally does, and you won't know why. Have one place where all of the information is recorded. I love Google Docs, but it's easy for your project to become sort of this semi-connected graph of Google Docs all over the place. If there are documents that are associated with particular stories, Tracker has a way to do file attachments. It also integrates with Google Drive, so even having the links to Google Docs in your Tracker is an improvement. But at the end of the day, it'd be great if there's one place you can go to that starts your search for project documentation, or maybe the repo plus one other place. You may have noticed that some projects, as part of their GitHub repo, have a wiki. A wiki is actually a great place to capture information of interest to other developers. So for the students who are going to pick up your project next semester or the following semester, the wiki is a great place to document things like, in order to get this to run, you have to first deploy Redis, or you have to deploy Mongo, and here's how you do it. Or this file, this project assumes that the following environment variables are set correctly, otherwise it won't work. Right, so things that a developer would want to know, that stuff can go in the repo. Things having to do with designs, mockups, things like that, if you can attach them in some way to Tracker, you can, and that's kind of the project home. Technical debt. Technical debt is things that you kind of know are wrong with your project, and you have let them slide, and at some point you're kicking the can down the road, and someone's going to have to deal with it. Things that are going to make your project difficult to maintain, especially for other people. What can you do to avoid accumulating technical debt? And by the way, it doesn't mean that your project doesn't work. You can have a piece of software that is functioning perfectly from the customer's point of view, but if it has a high technical debt, it means it's much harder for other people to pick it up and improve on it later. And as we know, part of the goal here is not just creating code that works, but code that is easy to maintain for others. So I've already mentioned this, but master should never be read. Having at least one invariant is really good, and having master be clean is as good as any. In terms of team practices, a few that you might adopt are, if a pull request lowers your code climate score by some threshold, it should be rejected. Right? A code climate score is a reasonable indicator of code maintainability. So if merging a certain set of changes would actually cause your code climate GPA to go down by a couple of points, That's kind of a big deal, right? At some point, even if all the tests are functioning, it's going to be somebody's problem to learn how to deal with that code. So do pay attention to what code climate tells you, and it's realistic to reject or at least ask someone to revise their pull request if it doesn't pass muster with code climate. If branches get too long, they become impossible to merge. So a branch shouldn't really have a reason to live for more than a day or two. Again, if you're trying to do break up the work into small pieces, there is no shame in doing a lot of one-point stories. And if that means that you have a small branch and the branch has a lifetime of a day, that is great. That is where you want to be, because each individual piece of work can then be pulled out or pushed back in as needed. So no piece of work is too small to be thought of as a feature that deserves its own branch. Any merge or PR that actually breaks the regression is reversed, meaning the merge is undone. You shouldn't really get to this point, because before you do a PR pull request to have your code merged, you should already have verified that it passes all the tests. But you can imagine this happening if the tests have been improved on master since you did your changes, and now there are some new tests that didn't used to exist, and those tests find new bugs in your code. Right? So again, this is part of never push red on master. And this is just me, but I believe in testing. If you're adding new code, you have to be adding tests that cover that new code. If you're fixing a bug, part of fixing a bug is a test that demonstrates that the bug was present in the absence of your fix and absent when your fix is applied. So if new code is submitted without the corresponding tests, that's a reason to reject it and say, go ahead and reopen your pull request after you have provided some tests that cover your new code. Because at the end of the day, everybody in the team is going to have to live with it. So concluding remarks about all this stuff. Small teams are good. They're not they're not magic. Banquet teams, if you want to think about a big organization with 30 or 40 people, a lot of the management problems associated with teams become much easier when you have a smaller team. In particular, staying in touch with what your team is doing through very lightweight daily stand-ups that could take as little as 5 minutes to do. Being able to use these informal mechanisms like points and velocity to have small chunks of work that are sort of easy to check off and that map nicely onto branch per feature. In a plan and document top-down environment, the project manager is sort of on the hook to do all of this stuff. I think it's both a pro and a con that in a team setting, you share responsibility for this. So if everybody sort of pulls their weight and you are checking in pretty frequently with each other, you can actually avoid a lot of the problems that larger teams have. And each iteration, think about what you've learned during the previous iteration. We actually are going to be providing a tool for you to do retros, iteration retrospectives. Things that went well or went badly could be technical things. It could be the way that you ran your scrums. It could be something about pairing. But basically, it's what would we do differently next iteration? Because if you're always improving, if you're learning from your mistakes, that's kind of the reason to make them. As you go off to your spring break, I will leave you with this thought. This is a post that I found. I can't remember if it was on Facebook or Reddit or where it was. When I die, I would like the people I did group projects with to lower me into my grave so they can let me down one last time. Oh, no, wait. But there was a comment. There was a comment on it that I thought made it even better. Your coffin will probably end up sideways because one person didn't hold up their side. Okay? Don't be that person.
All right, so a few quick comments on that. First, we talk about the size of the team. The ideal size is 2-piece team. That's roughly 6, 7-ish people in a team. And then and some team may get bigger, like to 10, 11, 12, but no more than that. And then there certainly are projects that will need more developers than just like 12. So how do we handle that? The way to handle that, it actually connects to what we've talked about earlier, to architect the application or the system into microservices. So meaning we basically break it down into microservices, and possibly one of the popular option is to just expose RESTful APIs for the other layer or for the other part or components of the system to consume. So that way you could keep the teams under the size limit while still being able to work on a bigger project. So keep that in mind, and that's actually where like the concept of microservices were like coined, because yeah, two-piece team is good, but how do we handle bigger projects? And then there's the idea of microservices. And honestly, I personally never worked with a team bigger than a two-piece team. So I honestly cannot say what can go wrong with a large team. But I kind of can imagine, like, just with all the communication required, when there are more people, at least the overhead for the communication gets worse. And then probably the team would end up spending too much time just communicating, and less time in the actual works. And then if they're not communicating enough, probably there will be miscommunications, and then which can potentially cause like bugs or even worse situations. Alright, so that's the size of the team. We talk about Scrum or daily stand-up. I think it's good practice, just to keep everybody on track. And especially, I think on average, developers are more on the shy side. So we tend not to talk about problems, or especially, the roadblockers, things that's in a way that can impede the progress of the project. So using that chance, it kind of help and encourage developers to talk about the challenges, the problems they're facing, and sometimes it really helps to solve the problem much quicker, rather than one developer just try different stuff by themselves and take a long time to find a solution. And also it helps to catch some potential bugs early on. For example, someone made a change, not realizing it could affect the other part of the system, or the other team member might know that better, and through a stand-up meeting, it can possibly prevent or catch a bug early on. Although, like when we talk about stand-up, it kind of also only works with a matrix structure. If you still remember what we talked about last week, where a team is structured by their department, but also by the projects. So basically, each team or each two-piece team would have stand-up, not like the whole team. Let's say a project is big, then it requires like 10 such teams to do the work to build each individual components. Then the stand-up is not like 10 team, everybody stand-up, it's just within one team. And then typically I think there will be a like weekly, bi-weekly, or even monthly sync meeting to have each team's rep group together and have a separate meeting like that. But again, you need to get that big before you need to worry about that. The other thing is Git. Actually, we've already used Git. I actually forgot that I should prepare some brief overview about Git at the beginning of the course, since we use it pretty heavily, at least for the hands-on assignments. You need to know some basics. But anyway, Git is really an essential tool for developer nowadays. To basically version control your source code, and it helps the team to collaborate. I still remember the days where I didn't even know version control. One of the projects during my college days, I just did version control manually. It was actually for my thesis or capstone project. I was developing a piece of software. I had no idea about version control, and it was for the semester, so the project lasted like 6 months. So I ended up like making a copy or making a backup copy of the entire source code pretty much every week, or if there's some breaking changes, I would just even make it every day. And then I ended up with a super messy source code repo. It's just a super huge folder with each subfolder time-stamped. But that was a funny story of me. Just, now you know Git, so just learn it. It's actually not that difficult to learn. And then you can find the materials in that sassbook.com or .org. That site you can find some tutorials and learning materials. Okay, and then in terms of Git Workflow, I pretty much just agree with what the professor said. Every feature, start a new branch, and then the master branch should always be safe to deploy. So the other alternatives I've tried, one popular is called Git Flow, if I remember correctly. You can probably just Google it, Git Flow, and then I think there's a decent article describing how that works. It's just a different branching strategy. I tried that, and then it's actually pretty cumbersome to work with. I think it's just too much overhead to manage. What it does, it kind of have a development branch, a staging branch, a production branch. It kind of maps to each environment, and then it also do all these feature branches. It will have release branches, and then have stuff merge and rebase back and forth. I mean, it's not bad, but I think it's just a bit too much. So nowadays I just end up with what the professor here described. Just master branch, and then if needed, new branch for every new feature. And then sometimes required, I would do a hotfix branch or a temporary branch to deploy the application, like roll it back to a certain version, or just deploy a quick fix. But otherwise, it pretty much stays that way. All right. So yeah, that's about that. Let's get to the next video.
Branch per feature. So right before lecture, there was a student who was asking me about this. And so I'm going to preface this by saying that this is a highly opinionated part of my class presentation. There are many different schools of thought about how to do development as a team using Git and branches. I'm not going to say that any of those approaches is wrong, but our experience has been that in a class setting like this, with teams that are maybe not quite as experienced as a team that's been in industry for several years, we really recommend that you do it this way. We think it will be less pain. But I am not saying that this is the one and only true way to manage work as a team with Git branches. And I will talk about at least one of the alternatives, which some people call trunk-based development. So what does branch per feature mean? It's pretty simple. As you're probably aware, when you start a new repo, the sort of default branch on that repo is called the master branch. But at any time, you can create a sub-branch off of it. And you can even create branches off of the branches, although the graph gets pretty hairy pretty fast. If you've tried doing this, you probably have seen that creating a branch is basically free. Like, it doesn't take any time at all. Unlike, for example, forking a repo, which takes up to a minute. But creating branches is free. Switching between branches is really easy. Every branch has its own commit history. So branches, once you have created the branch, anything you do there is invisible to any other branches until you somehow do a merge operation, or by deciding that that branch is going to die and those changes won't go anywhere. The methodology that we recommend for small teams working with a single repo is branch per feature, deploy from master. So roughly speaking, what that means is when you're going to create a new feature that's a programmer or a pair of programmers, you immediately do a branch off of master. You limit your work on the feature to that branch. And using one of a couple of different mechanisms that we'll discuss in a moment, you eventually get those changes back into master. And you maintain the invariant that at any time it is always safe to deploy from the head of master. That gives you sort of a stable point. So if something goes horribly wrong, or if some code that you put into a feature branch doesn't quite work, maintaining the invariant that master is always safe. And one of the reasons that we really want teams to be using Travis and code coverage and things like that is then you get instant feedback, right? If you break master, you'll know it right away. There's also an additional layer of safety if you want, is that you can use a release branch. So this sort of adds a layer of insulation, which is when you're getting ready to do a release, rather than releasing from master, you first do a branch off of master, and then you use that branch as the release point. Because that way, even if you manage to screw up master, if you violate the invariant that is always safe to deploy from master, you still have the tip of the release branch, and you know that's safe because that's where you deployed from, right? And you can roll back to earlier releases that way as well. So what does this workflow sort of look like in practice? You create a new branch just for the feature. And in my book, and when I say this is how I personally do my development. There is no such thing as a feature that is too small to deserve its own branch. Even if that feature is just going to be like making a simple change to a view or adding a filter to a controller method, even if I think it's going to be just 1 or 2 lines of code, make a branch, because there's no cost to making a branch. Which means, of course, a lot of features can be in progress at the same time. The second thing, and this is really important, on that branch, only do the things for that feature. Don't do anything else. So you started your branch, you started your feature, and you realize there's a typo or a bug or just something that looks ugly somewhere in the code. And it's like, oh, while I'm here, let me just fix that. Resist the temptation to do that, because one of the reasons to do branch per feature is that it makes it somewhat easier to isolate the changes related to one specific thing. If you later need to undo the merge of that feature, you don't want to take with it other cool stuff that you did in the branch that actually have little to do with the feature. Which means that backing out a feature, for the most part, is undoing a branch merge, which isn't trivial, but it's actually not the most painful thing in the world. So keeping the branch only for the changes needed for that feature. And the rationale is that if your app is reasonably well factored, conflicts when you do this should be relatively rare. And we'll talk about how to deal with conflicts in just a moment. So in my hypothetical diagram, the master is this kind of middle horizontal line. Amy, Bob, and Dee have all started feature branches because they're working on 3 different features. Bob runs into some trouble and decides his feature is actually not going to work out, so he just lets his branch die. You can let a branch never be merged back and just say, delete it. This experiment failed. Amy is the first to actually finish her feature, and she will eventually cause her features changes from the branch to be merged back to master. That's great. When it's time for Dee to merge features, there's a possibility that some of the files touched by Dee's commits may also have been modified as part of Amy's commits. Now again, in a well-factored app, it should be relatively rare that the same lines of the same files are modified, because that suggests that Amy's feature and Dee's feature were maybe not as separable as they thought. But in the normal case, even if there aren't going to be hard conflicts, Dee may be required to essentially do an update and get the latest version of master in her repo before it's possible to clean up the merge. So we'll talk about different strategies for doing a merge, but the message here is if you're trying to do a git push and you get this message that says there are non-fast forward references and you have to do a git pull, it doesn't necessarily mean that you're going to have to resolve a merge conflict manually. It just means that there are some commits present in the branch into which you're trying to merge that are absent from your branch. So something has changed out from under you since the time that you did your branch. You need to make sure that you have the latest version of the branch you're merging into, And then as you continue the merge, you can see whether, in fact, there were conflicts that require manual resolution. And we'll talk about how that's done. So by the way, what is if you don't do branch per feature, what is the alternative to doing something like this? Some people call it trunk-based development. And basically what it means is no branches ever. So when you make a code change and you commit, you're committing to master. And ideally, there's some place from which it is always safe to deploy. You could be saying that it's still the head of master. You could be using release branches where when master reaches a point everyone agrees is stable, at that point you create a branch and say, OK, we're going to release from here so that as we continue to change master, at least we have a safe place to go back to. We know that if we have to fix the deployment, we can always go back from here. So there's this question. And by the way, Facebook is known to use this development model. Facebook, at least as of last year, they used a model where commits generally go to the master branch. I'm not going to say that that's a wrong way to run a business, because Facebook's doing OK. But I do think that you have to have safeguards in place somewhere to make sure that when things are committed to master, stuff is not breaking. Now, one place to have those safeguards is you're doing your development on a branch. You can break stuff on your branch, and that's fine, as long as before you try to merge anything back to master, you fix stuff on your branch. If you're not using branches to have that isolation, what safeguards do you have to make sure that when you commit to master, you're not stomping on something important or breaking something important, right? And at a large, sophisticated company, there are many such safeguards. Google has all kinds of safeguards in place before your commit is even allowed to happen. And those safeguards include test-related things, code style-related things, human beings signing off related things. So yeah, you are committing to master instead of doing a branch, but the process of committing to master itself has a bunch of safeguards built in. Because I don't think it's practical in this kind of a class setting to do that, our high recommendation is to use branch per feature. It's not a magic wand, it's not a panacea, but it saves you from certain kinds of pain. So I'm going to continue on the assumption that most of your teams are probably going to use branch per feature or something like it, and talk about what the pitfalls are of how you might accidentally misuse it. So what are the mechanics? Pretty simple. You create a new branch and you switch to it. You make your commits, et cetera, on the branch if you're working with a pair. You might be pushing the branch periodically back to the origin repo. GitHub is a great place to back up your stuff. Plus, you can have it configured so that when you push a branch, it'll run the regression tests on your branch, and you'll know if you broke something. Now, at this point, if you're working solo, if you're working not in a team, most of the time, when you get to the point where your branch is ready to be integrated, the next step would be you go back to master and you say, merge my branch, right? Something like that. If you're working in a team, though, this is not necessarily the best way to do it for a couple of different reasons. First of all, using the diagram from the previous slide, if you're doing a merge, and since the time you began your branch, other things have happened on master, there's a good possibility that doing that merge is going to require you to resolve some sort of conflicts. Maybe it's just sort of verifying that the conflicts aren't like the same line of the same file, but something will happen, right? So as a human being, you're going to have to look at the code and say, OK, even though things have changed out from under me on master, I'm confident that the merge is not going to break anything. And this, in some sense, this puts the onus on whoever is keeping track of having a clean master to do this. So the alternative is to do a rebase instead. And this is the mechanism that we'd recommend you use. So essentially, to rebase a branch against some other branch essentially means try to pretend that it was branched from that commit. So here's an example where just after the very top commit, a branch was created. Some commits have happened on this branch. And in the meantime, other commits have happened on master, probably as the result of merging other features. So now, if at this point we were to say, try to merge this branch back into master, the changes that we made and the changes that were made here are going to require some resolution. Maybe there won't be any hard conflicts, right? That could happen. But something about the fact that master changed out from under you is going to have to be dealt with by someone. So a way to do that sort of takes the burden off of whoever is in charge of keeping an eye on master is say, at this point, I would like to rebase against the master branch. What that means is, originally master was there when I branched. Now master is in this state. What happens if I essentially try to put my work aside and replay it on top of this commit? And in many cases, in a well-factored project, it'll just work. right? Whatever these changes are may have nothing to do with the changes you made. So you're basically going to say, I've got these changes. Now I'm going to replay my commits on top of them, and maybe no manual conflicts will happen. If manual conflicts do happen, you still have to fix them. But now, in some sense, the onus is on you to fix them. Because if you rebase against here, and you fix all the conflicts, what that means is that now you're in a position where if you do a merge, the merge is clean. Right? You're guaranteed that, unless, of course, it takes you so long to do the fixes that in the meantime, more changes happen on master. But we hope that's not the case. Right? So rebase is basically saying, as the branch owner, I'm going to take responsibility for making sure that when we merge to master, it's totally clean. And the way I'm going to do that is I'm going to first rebase against the latest master, do any cleanup that's necessary there, so that by the time my rebase is finished, it's guaranteed that if I then merge to master, the merge will just work. Because it's as if I had branched from here, made my changes, and then immediately merged them back. Right? And by the way, rebases can be complicated. If it turns out you have a lot of conflicts, you're sort of going to be in this limbo state of rebasing for a while. But you can abort a rebase. You can say, oh my God, stop this and go back to the way my branch was before I began trying to rebase. You can try to manually do some fix-ups and then try rebasing again. But in all that time, you haven't screwed up master, and that's really important. So it helps maintain this invariant that the tip of master is always a good place to deploy from. Once you resolve the merge conflicts, then should you actually merge to master? I would say no. Because if you're working with a team, part of the benefit is having other people kind of look at your code with another pair of eyeballs, not only to find mistakes, but also maybe to catch things that you might have done a little more elegantly or something. So instead of doing the merge, you do a pull request, which is basically, excuse me, basically is a way of saying, I would like to merge my commits from the branch back into master. And if you've used the pull request review mode in GitHub, it's really nice. You can see the differences between the files in different colors. You can attach comments to like specific lines of a file. So the pull request really is almost like a miniature form of code review, which I'll talk about more in a moment. But the expectation is that when you make a pull request, you're making it against a branch that has already been rebased. So accepting the pull request is guaranteed not going to cause a conflict. So the only thing the pull request is there to do is essentially make a public announcement to your team, hey, I want to contribute this code. I would like everybody else to take a look at it before I do that.
All right, so another quick comment on that. Basically, almost always use rebase instead of pull and merge. Just per my experience. Although when you go through the basic Git tutorials, usually what you will first learn is fetch and then pull, rather than rebase. But in real life, it's almost always more. It makes more sense usually to just use rebase rather than pull or merge. But because it makes a pull request much more cleaner. And yeah, all the other good reasons that the professor already mentioned. So yeah, if there's only one takeaway for this part, it will be always use rebase unless you have a really good reason to use pull or merge. All right, next one.
Which means that in some sense, pull requests are code reviews. So opening the pull request means that you expect anybody on the team who might be affected by that code to at least take a look. And one of the many safeguards at Google is that there's no code that gets checked in unless at least one human being on the team has looked it over. Even if all they say is looks good to me, no problem, right? We actually think that it is a very good practice that anytime you have a pull request in your team, at least one and ideally more than one person will take a look, make some sort of comment. Again, even if the comment is just looks good to me, right? That says, I have actually scanned the code you want to check in. I know that you've run the test, so there's no issue with test passing. I know there's no merge conflicts because you're rebased. But the code itself, like I think your changes, I don't smell anything unusual. If that's not the case, if people do find problems, they can leave comments in the pull request. You can modify the pull request in place as you address people's comments. You can actually close the pull request without merging. So basically, I'm going to withdraw it. Let me go back and work on my code some more, implement your suggestions, and then you could reopen a new pull request. And again, now you might have to rebase again, because in the time it takes you to address their comments, maybe master has changed again. But basically, this is how GitHub works. There's a great talk that I'm sure you can find online, whose title is something like How GitHub Uses GitHub to Develop GitHub. And basically, this is what they do. They don't have formal code reviews within GitHub pretty much at all. Their code review is the pull request. And the benefit of doing it that way is that any individual code review act is pretty compact, because the branch per feature philosophy says, even if the feature is pretty small, do it on its own branch and contain all the code changes that are related to that feature. That makes it easier for your colleagues to look at it. What they're looking at is a very limited set of stuff. Right? So this is actually a very good way to do development, and we certainly think it works well. Historically, has worked very well for 169 projects. So what are your goals? Don't merge red. Right? It's fine if you have red, meaning red failing tests. If they're in your branch, that's normal. Right? That's what branches are for. It's to give you a place to get it right. But you should never be doing a pull request where the thing that you're trying to merge is failing some tests, because that means that now master is going to fail those tests as well. And that probably means that you may have had to change tests on your branch also. And like I said, our suggestion is your secondary goal is to keep master always safe for deployment. That gives you sort of an invariant. Okay? So in industry, you'll find different ways of dealing with branches. Branch per feature is certainly one of the most common ways, not the only way. We have found it to work well in scenarios like this, and there is no feature too small to deserve its own branch. Really no feature too small. It's free to create a branch, and it's just as free to delete the branch if it really was a trivial change. So what does that look like in terms of the overall project workflow, which you're now starting to get familiar with? So some of these projects started from or had to create a golden repo. That's the repo that we, the CS169 organization, are the owners of. The reason for that is so that when you all are gone to greener pastures, we can keep these projects and have the next crop of students work on them. So you have then forked that golden repo to your team's repo. Our recommendation is that the individual team developers clone the repo. There's an alternative to this, by the way, which is that if you have n developers, each developer could have their own fork. We don't particularly think that that adds any value for a team of size 6, which is what most of these teams are. In particular, if you've got multiple copies of the repo, and now you're doing pull requests across the repos, it's just more things to keep in sync. And I think if you're running a team pretty tightly and your team is in communication, everybody's sort of on the same page about what's going on, it is a much lower development overhead to do things at the level of branches within a common origin repo than it is for each team member to have their own fork of it on GitHub. Again, it's not that you can't do that, but we found that it adds complexity, it adds management overhead for you, and it's not clear that it really adds a lot of value. Each developer will then have their own clone of the repo, but there is one GitHub origin copy of the repo. And ideally, you're all going to be doing great branch per feature, nice clean development, doing pull requests to get your, oops, what did I do? Doing pull requests to get your features merged back into master with good test coverage. And because you're all using Travis and Code Climate, once you get them properly set up, which the first time you do it is a little tricky, but once it's set up, it's really nice because it kind of just works. So you get the nice little green badges saying that your build is passing. By the way, of course, there's no real build step for Ruby apps, right? You don't have to compile them. So what we're using Travis for is to actually run all of your tests. So the badge would be more accurate if it said regression passing or tests passing. We got you hooked up to Code Climate, so you can see whether the code you wrote is maintainable. I think they've actually renamed the badge now. It used to say Code Climate and then a GPA. Now it says maintainability and a GPA. And I think maintainability is actually a better description of what the badge is measuring. And then test coverage. A quick clarification about the test coverage thing, because I know some people had trouble setting it up. I'll get to that in a moment. You're deploying to Heroku. Your customer is using the Heroku app and giving you feedback. Everybody is happy. And by the end of the semester, if not earlier, our hope is that you'll be able to do, or you will have done, one or more pull requests from your team's repo back to the golden repo. So those features become a permanent part of the artifact that future groups of students are going to work on, right? So, my kind of, if you had a bright line test of like, do you have a successful project? If you do one significant PR back to the golden repo and that becomes part of a permanent code base, that is success, right? That in an 8-week, 4 iterations, you've been able to make a permanent contribution to a piece of software is actually kind of a big deal. And it's a piece of software that, remember, has to be able to survive and be maintained long after we can no longer get a hold of any of you, right? So to be able to say, I contributed something that's become part of a piece of software that, and now it has a life of its own separate from me having contributed, that's a really big deal. That's a great thing to be able to say when you're talking about interesting software positions. A clarification, because there was some confusion around where this coverage badge comes from. So Travis CI is designed to be a very general environment for doing builds and tests. It's language agnostic, which is why it has that whole travis.yml file where you have to tell it in great detail what to do. What comes out of Travis CI is thumbs up or thumbs down. Because it is language independent, you have to write your Travis scripts or use the one that we provided as an example so that at the end of the day, Travis tells you either everything works or something didn't work. And in particular, Travis itself can't do things like measuring test coverage because the way you do that is very specific to a particular language. So the recommended setup that we provided a file for, what it's actually doing is Code Climate has provided a test reporting coverage tool that can be part of your Travis run. And what our example file tries to do is right before Travis begins running all of your Cucumber and RSpec tests, it starts up the test coverage reporter, and after each set of tests is run, it records how much coverage those tests gave. At the end, it merges the coverage results from Cucumber and RSpec, which is actually pretty important, right? Because your Cucumber test will get some coverage of the code. Ideally, your RSpec test will get more coverage into those places that are hard for Cucumber scenarios to reach. And you need to sort of merge that information to get sort of a single scalar of what fraction of C0 coverage does your code achieve. And that's where the badge comes from. So the badge is served from Code Climate, but Code Climate is providing a tool that Travis runs that collects the information, and at the end of your Travis run, it sends that information back to Code Climate right before it exits. Right? That's what that token is used for. It's for Code Climate to allow Travis to pass that information back so that they can report it alongside your maintainability score. So that's how that all works. And I know it's a little bit of a pain to get all the moving parts set up, but this is one of those things that once you get it set up, you're rewarded manyfold, because having constant monitoring of your test passage and your Code Climate is really, really good.
All right, straight to the next one.
OK, continuous integration and continuous deployment. Continuous integration you've basically all been using, because hopefully by now it is all properly set up that every time you push new commits back to GitHub, you get your automatic Travis CI test run on all of that new stuff. Not sure how many of you have moved to continuous deployment. And the extreme version of continuous deployment is you can actually set it up so that every time you push and Travis runs and everything passes, you could have it automatically then also deploy to Heroku without you doing it manually. Depends on how lucky you're feeling that day. But the big message is that the idea of continuous deployment is a relatively new idea. Windows 95, I know it's like before a lot of your time, but when Windows 95 launched, like they licensed the tune Start Me Up from the Rolling Stones so that they could play it at the Windows launch celebration. They paid to have the Empire State Building in New York light up at the top with the Windows colors. I mean, it was a release. It was like the turn of the millennium or something. Releases today are almost a non-event. As of late 2011, when I heard a really interesting talk from the then director of engineering at Facebook, he said it was not unusual to push the master branch once a week, and they were trying to move towards more like once a day. I don't know if anybody has interned or worked at Facebook recently and is allowed to say how often they're pushing new features to production. I realize they have other concerns going on right now. But at Amazon, AWS and the Amazon.com site are usually deploying several times a week. And a lot of the times, as an end user, you might not even see the effects of some of those deploys. And we'll talk about some of the reasons that might be true. Stack Overflow, heard a great talk from Jeff Atwood about this. They do multiple deploys per day. So if they're doing multiple deploys per day, what can you conclude about that? First of all, deployment has to be automatic. If deploying is anything more than pushing a button or typing a command line, it's not reasonable to do it several times a day. Second, any individual deploy doesn't have a lot of changes in it. It's probably changing a relatively small amount of stuff. What would be the motivation? If you've got, if you're going to do 8 or 10 deploys per day, what would be the motivation for doing that as opposed to like waiting until the end of the day and batching all those changes together into a single deploy? Why do a lot of people consider that it is actually less risky to do a lot of little deploys instead of like one major one per day if you can get away with it? Yeah. If you break something, right? The less you changed, the less you're likely to break something. And if you do break it, you know where the break is. It's the same as the motivation for doing TDD and doing frequent commits. If you're doing TDD and your tests are running and you add like 6 more lines of code and now something fails, you know the problem is in those 6 lines. If you're deploying and each individual deploy only has a few dozen new lines of code in it, then if you break something, you know right away where you broke it and you can roll back. So it's the same idea as behavior-driven design. The more you talk to the customer, the more you cross-check your assumptions, the less time you'll waste when something actually does go wrong. GitHub does tens of deploys per day. That's from Zach Holman, who until recently ran engineering there. And the rationale is exactly what was just said, which is how many engineer hours have been invested in the product since the last deploy? Because that number of engineer hours is proportional to the likelihood of something having gone wrong, right? Of introducing something that you did not expect. So just like development and just like doing features, the ideal deployment scenario is one where it's such a non-event that you're comfortable doing it all the time. And as I said, in fact, you can configure Heroku and GitHub to work together so that once your CI passes, you can automatically have it deploy from that branch into your staging environment. So to have a successful deployment pipeline, what do you have to have? First of all, you have to have automation. It should really be the case that it takes a single command line to do whatever deployment means for you. And by the way, that's not just git push Heroku master or whatever. Part of it is also the implicit discipline that it is always safe to say git push Heroku master. That in fact, if something has moved onto the head of master, as far as everybody in the team is concerned, it is safe to deploy that thing to production. So it's not just the deployment part itself, it's the discipline you're following about what assumptions you can make about your product. Heroku is really good as far as the mechanical part, because literally it's just like pushing, as you know, to a Git repo causes the deployment to just happen. But if you're not using platform as a service, there's a whole menagerie of tools out there that allow you to manually create scripts and config files to do what Heroku basically does for you. And continuous integration, which all of you pretty much have already been doing. Basically, you're always doing test runs. You're certainly doing them before the decision is made that the branch is safe to fold into master. If you're doing frequent push-ins and frequent check-ins, then you're doing frequent continuous integration. So again, if you break something, you'll know pretty quickly what broke. And a strategy is to integrate CI with GitHub, which is the steps that we have tried to make work for all of you so that every time you do a push, you get an automatic CI run. Reasons to use CI, differences between development and production. We've sort of said that before, but if your production environment, you can run tests in CI that are too expensive to run in your development environment. And you can run staging tests as well that require pushing a separate staging server out. Most of your projects are sort of not big enough to make that additional hassle worthwhile. But for example, in one of the apps that I maintain, besides the production server, I have a separate staging server where certain additional tests get run that are not part of the test suite. Cross-browser testing. There are now facilities to, if you have a really JavaScript-intensive app, you can test it with all kinds of different browsers and make sure you haven't done something that breaks them. Testing the integration with other services when the remote services act wonky. So having a staging server that actually realistically tests remote integration. So instead of stubbing out, let's say, the calls to Stripe, you're actually calling Stripe, but you're calling their sandbox server. Something that is not really practical to do from your development environment all the time, but is reasonable in a staging CI. If you want to run, simulate doing attacks against your code, that's something that, again, you wouldn't want to do on your local machine. Stress testing, trying to sort of hammer an app with a lot of traffic. Again, something you could set up in an external environment but is not really straightforward to emulate on your own. As one example of this, Salesforce, which is the original software as a service, has hundreds of thousands of tests that are not only automatically run during CI, but they automatically open and assign a person to a bug report if one of those tests fails. So the more automation in that workflow, the better. And then continuous deployment, basically, as I said, you can actually auto-integrate so that every time you do a push and it passes CI, you can have it deploy automatically. So in some sense, you don't have to do any extra work to make sure that the most recent version is always running on Heroku. And the question is, if this is what releases are like now, does this mean that the concept of a release has no meaning anymore? Not necessarily. There are customer visible milestones where you say, hey, on this day, we're going to provide you with features A, B, and C. And maybe those features actually make sense to deliver together for whatever reason. So even if feature A is already present in the production environment, maybe the user interface to allow the user to get to feature A has not been deployed yet. So you can have code in production that is not really active, but at least you know that when it's under normal operation, it hasn't broken anything. One way to do this is that if you have a particular release that makes a set of features available to the user, you can choose to tag it so that when you're talking to your users, you can refer to which release they're using. Android does this with things like Marshmallow and Ice Cream Cone and stuff like that. Or you can just use the unwieldy Git commit ID to identify a release. But basically, the idea is you still have the concept of telling the customer, hey, this is going to go live at a certain point. That doesn't mean that you have not been deploying up to that point. It just means that's the point at which the feature becomes ready for the customer to use and possibly available through the UI. But in the meantime, code related to that feature could still be in the production build. It's just not getting exercised yet. But at least you know that it isn't breaking anything else. OK, well, I hope you're excited because finally, it's time for your team to code. Well, code and test, of course. So we're going to talk about how an Agile team functions when they're sort of in their steady state mode of getting work done, coordinating with each other, getting that work into the main code tree. And this whole workflow kind of goes into the general name of continuous integration, or CI, because each team member is continuously integrating their most recent code with the mainline code branch that represents the deliverable product. So at this point, we're going to assume that this is where your team is at. First of all, that you have prioritized and assigned points to the stories that you're going to work on during this iteration. That's what happened in the iteration planning meeting. So I've got some stories here. I have sorted them in the order of importance with the most important ones at the top. I've estimated the number of points each one is worth. And you can see that they're all in the unstarted state. If I were to click the start button, that would be me claiming a story and saying I'm going to start working on this story. Second, your team has a shared GitHub repo. Doesn't matter who on the team owns it, but everybody on the team has the ability to access that repo, and in particular to do pushes against that repo. Third, that repo is probably linked to a continuous integration or CI service, such as Travis. Now, by the way, I recognize this is confusing. Travis and other services that run your tests for you are called CI services, but we're saying that this whole process of integrating your work on an ongoing basis is called CI. Both are true. Live with the difference. Sorry, folks. Optionally, you might be fancy and have a staging server. That's a server where you can push a copy of the latest features in the app and have the customer play around with them before you actually put those features into the production server that the customer uses. So don't worry if you don't have that, but for completeness, we're going to assume that you have a staging server that is separate from production. And you can read more about staging servers and how to work with them if you read the more detailed version in the book that covers the same material. So we're now ready to assign stories to developers. And by the way, whenever I say developer from now on, it could be a pair if you're doing pair programming, which we highly recommend. Doesn't matter. Now, this looks like a busy diagram, but don't worry, we're going to go through it step by step. And in this diagram, we see two different copies of the repo. There's the shared team repo called the origin. That's the horizontal line across the middle. And there's your developer copy, your local repo, which is probably a clone of the origin repo. That's the lower horizontal gray line. And like all workflows, the first thing you do before you start making any changes is you need to make sure you've got the most up-to-date copy of everything that's in the team's shared repo. Everybody should be periodically syncing to make sure they start from a shared state. Which means the very first step in our workflow is to do a git pull or a git fetch to make sure you've got the most up-to-date copy of what everybody else has seen. Okay, so you're ready to start working on your story. Your partner and you are raring to go. And the first thing you do, of course, is you create a feature branch. This lets you make sure that your changes are going to be isolated and not affect the master until you've had a chance to finish and test them pretty well. So you start developing on your feature branch. As you develop, you're making frequent commits, of course, and each one of those gray circles is a commit on your feature branch. But you also have to push those commits up to the origin repo, because otherwise the rest of the team won't even see that. In fact, they won't even see that you've created a feature branch. So you're periodically pushing those commits to a branch on the origin repo that tracks your own branch. And in this example, we've set up the origin repo so that anytime anybody pushes, whether it's to master or to some other branch, it automatically kicks off a CI run, continuous integration, to run all of your tests, and you'll know immediately if you broke something. Now, of course, while you're developing the feature, you're writing tests for the feature that you're doing, but running the continuous integration on every push to the origin repo means that if you accidentally broke something far away in some other part of the app, you'll know about it really quickly. Okay, finally, you're done with your tests, you're done with your code, everything is in good shape, you've pushed the latest version of your feature branch to the origin repo, and now you're going to ask the rest of your team essentially permission to merge those changes into the master branch. So you do that by opening a pull request, and that's the little line with the circle on the end. This means I want to merge the contents of my feature branch into the master branch. What do you, the rest of my team, think about that? Have a look at my code, do a sanity check, see if it looks good to you. Now, keep in mind that the pull request is comparing the feature branch on the origin repo with the master branch on the origin repo. So the pull request is happening within that copy of the repo, but between two different branches. That's important, and we're going to come back to that later. So your team is taking a look at your code. Sure, your tests all work, but they maybe found a few places where there's a few things that are a little messy and could be cleaned up. So your team gives you the feedback. We think that you should fix up these things and then reopen your pull request. Okay, well, that discussion is really important because once code gets merged into the master branch and becomes part of the stable code base, you're kind of stuck with it forever. So it's worth taking some time for everybody who might be affected by your code to sort of sign off and say, yep, looks good to me. Okay, in this case, your team has given you some feedback, so you go back, you make some more changes, some more commits, you push those commits to the origin repo, and this time you do a pull request again, and voila, your team has decided now you're good to go. You fixed all the issues, your pull request is accepted, and now your feature branch's code gets merged into the master branch again of the origin repo. That's great news because now you're one step closer to what you're really trying to do, which is solve the customer's problem. So typically, the next step at this point would be from the master branch of the origin repo, deploy that new merged code on a staging server. And by the way, notice that when we accepted the pull request, there was a CI run that happened there too. Because if other developers had had pull requests merged since the time you began yours, remember that what's being tested now on the master branch is not just your changes, it's your changes possibly added on to other people's changes. So doing that CI run on every push or merge is really important. Anyway, let's say things are good to go. Now you deploy on a staging server. A staging server is set up to look pretty much like production, but usually a lot smaller. Maybe it has some fake data that could even be extracted from the real data, but it's a place where it's safe for the customer to kick things around and not worry about screwing up their real app. So now the customer gets to give feedback on whether the features behave the way that the customer expected. That's the all-important customer interaction part. And again, in this example, we've chosen to show that the customer has actually made some revisions and said, actually, I think I want a minor change in how you did this feature. Okay, well, we know what to do. We go back to the workflow. We go back to our local copy of the feature branch. We do some more commits. When we're happy with our tests and our code, we once again push our feature branch up to the origin, and we reopen, or maybe a new pull request, saying, okay, here's my pull request, further revised because of the changes that the customer asked for. And at this point, the customer once again views the code on a staging server. The code is good to go. The customer leaps in joy and decides that the story is delivered. And now you can deploy that same code to production. So notice all the action here on this very last merge commit that happened on the master branch of the origin repo. It was a merge of our most recent changes. It triggered a CI run, again, to make sure that since other people have also been changing the code, our interaction between our code and their code hasn't changed anything. It was deployed to a staging server so that the customer could sort of do a final sign-off, and only then did it get deployed to the production server, the real server. And by the way, notice what else happened. Once that's happened, we want to do a pull or a fetch of the team's repo back to our own repo, because again, the latest merge contains other people's changes as well as ours. So in preparation for the next feature we're going to do a pull of that team repo. That's the basic workflow, but now I'm going to show you a variation on it that can arise if your team is not necessarily the owner of the project that you're working on. So how does this workflow fit together with pivotal tracker stories? Well, remember when we began, all of the stories were in the unstarted state, but when a developer or a pair claims a story and they create a feature branch on their local repo to work on it, that is essentially saying we have started work on the story. And in fact, you can actually encode your branch names so that they're automatically associated with the correct stories in Pivotal Tracker. The story is finished. Well, in my view, the story is finished when I'm convinced that my tests and code are good enough that I'm opening a pull request. Now, of course, that pull request might not be accepted right away. I might still have to make other changes. So depending on your team's practices, you might decide that you don't really mark the story as finished until the pull request has been accepted and merged into master. Whichever one you choose is up to you. Just make sure everybody agrees on what it is. But at that point, the story is finished. It's not yet delivered, though, because until the customer can see it and give comments on it, we can't say we've delivered functionality. So I like to say that the story is delivered when we deploy that new code into a staging server and the customer has the opportunity to interact with it. And of course, once the customer is satisfied, maybe after another round of pull requests, and the code is ready to be deployed to production, that's when I say the story is accepted. And once again, your team might prefer to reserve accepted to mean that the story is actually deployed on the production server as opposed to ready to be deployed onto the production server. Really, all that matters is that your team agrees on what the correct meanings are. There's one variation I want to show you on this workflow, and this variation occurs when the team working on the app doesn't necessarily own the app. So for example, if you're working as a sub-team on an app that's owned by another organization, that organization's, let's call it the golden repo, I guess, where the app originally lives, is shown as the topmost of the horizontal lines on the screen now. And we're going to call that the upstream repo, because if your team doesn't own the app, you don't necessarily have push access on that repo. So the only variations to the workflow are these. First of all, in the beginning, you have to create a fork of that repo. You're not going to clone it, and we're going to talk about why in just a moment. But your team can create a fork of the original repo, and on that fork, your team can have all of the push permissions that it needs. You're going to go through the exact same workflow that we just described, except when the feature is ready to be officially and finally merged into the mainline code and deployed in production, instead of deploying it to the production server directly, well, you probably don't control that server if your team doesn't own the original app. So instead, you're going to do a pull request from your final commit that's merged to your team's origin repo up to the repo owned by whoever owns the app. And the same essential protocol is followed, where they're going to review your code changes. They may ask you to revise and reopen, but at some point, your pull request will hopefully be accepted. It will be merged into their master branch, and then they will deploy from their master branch to the production server, which they control. And finally, you now have to make sure that just as when you were developing on your own, you needed to periodically resync your team's shared repo back to yours, well, in this case, the upstream repo may have additional changes from other subteams, so you have to sync those back as well. And because of the way GitHub works, the machinery for doing that is a little bit weird. You actually have to pull those changes down to one of the clones, and then from the clone, push the changes up to your team's origin repo. You can read more details about that in the more detailed description in the textbook, which also contains some pointers to excellent tutorials and articles on GitHub itself about how to do these operations. But keep in mind that when you're working in this fork and pull model and there's an upstream repo that is where the app officially lives, it is because you fork that repo that you're able to do pull requests against it. So that's the only variation when there's an upstream repo. You begin by forking that repo to have your own team's repo. And when you're done, you're going to do a pull request back to the master branch of the upstream repo and get your changes pulled in that way. Now, in the workflow that we saw, there are two places where there are sort of loops, meaning that even though you did a pull request, your team might not accept it the first time. Or even though you deployed to staging, the customer might not be happy with the story the first time. Some amount of that is just a byproduct of an Agile workflow in which you're trying to keep communication constant between the customer and the team, right? Part of the whole point of Agile is you can make changes while it's still less expensive to do so. But there are things you can do and practices you can follow to minimize how often that happens and sets you back. We already said this when we talked about stories and points, but man, small stories are really your friend. A small story means that your code changes are going to be small, so your branches are going to be really simple. That means they can be short-lived because it doesn't take a very long time for your team to review your pull requests, and you'll almost never have to rebase. So even more importantly now, short stories are really good. Respecting your team's own work. If you spent time in the iteration planning meeting, it was to prioritize and assign points to those stories. Respect that priority because whatever you were thinking then, it's no less valid now. So as you start working on your stories, pull off whatever is at the top of that priority queue and work on that one next, not the one you think might be most fun. And work on one story at a time. If your stories are pretty short, then you should be able to completely finish one story, put it to bed, pull request it before you start another story and have a proliferation of feature branches and you're not really sure which branches have been merged back and which ones have not. Now, of course, if you're working on a story, you might unexpectedly discover that further progress is blocked until some other story is done, maybe even a story that someone else is working on. So when we talked about how you prioritize stories, you have to account for the fact that sometimes one story may block another and sometimes you don't find that out until you actually start working on the story. You do the best you can, but in general, try to stick to one story at a time and have it completely cleaned up before you move on to another story and create more branches. And work at a sustainable pace. Remember that velocity is supposed to be a rough measure of how much work you're getting done each iteration, but if you deliver all of those points at the end of the iteration, then you're negating an important advantage of this Agile workflow, which is having the team constantly able to comment on each other's work and sort of stay up to date with what's happening in the app. So delivering a small amount per day, which is another reason that one-point stories are great, you can knock them out quickly, and having your team review it as soon as possible, having the customer give feedback as soon as possible. Working on short stories one at a time will give you a sustainable pace. And over time, that's going to be much more important than getting the total number of points crammed in right at the end of the iteration, just to say that you were able to do it.
Okay, so that kind of sums up everything we touched about. For the day so far, it's basically how the Agile team would work in terms of the workflow from the beginning of the iteration all the way till the end, and all the way till a feature gets delivered and accepted or deployed to production. Okay, so next video.
Okay, so a surprisingly related topic has to do with bug fixing. Again, as I think we've told you guys a number of times, we have gone out various times to our colleagues in industry, and we sort of, every time we refresh the course, we do this to make sure that we're understanding the best practices that they use. And and when we went out to ask the question, what protocols do you have when a bug is reported, we were surprised at the variety of organizations that we talked to, even the ones that don't sort of strictly practice Agile development. One really important thing that they all had in common in terms of what a bug means to them. And what that was is no bug fix without a test. So we talked to a bunch of companies, and we sort of distilled this into what we call the 5 R's of dealing with bugs. A bug is reported. A bug can be reproduced, and it might be reclassified. Assuming that you decide that it really is a bona fide bug, the next thing is to create a regression test that repeatedly demonstrates the bug in action. Then and only then can you repair the bug, because it gives repair a very specific meaning. It means we have a test that fails in the presence of the bug, but once we apply the fix to the code, that same test now passes, right? That is a bright line definition of repair. And then, of course, you release the fix. And depending on how your team is run, release might be make sure it gets committed and merged to master. Release might mean that it gets deployed to production, but release in some fashion. So even non-Agile organizations do something very much like this. And basically, existing processes that you already know for developing features can be adapted to bug fixing. So all of the same machinery that you already use. In particular, when a bug gets reported, maybe it was reported by the customer because they were trying to use the app, something went wrong. Maybe your own team found it when you were sort of manually doing some testing and you found a bug that was not caught by any existing automated test. So just enter the bug in Tracker as a 0-point story. This is another one of those areas of controversy because you would say, well, fixing a bug is not a 0-effort thing. So if it's more than 0 effort, why are you saying that it should get 0 points? And by the way, Tracker has a setting that allows you to assign points to bug fixes. We have recommended to leave that setting turned off so that bugs are worth 0. But I think the rationale is that in an ideal world, the bug shouldn't have happened. You should have been able to catch the bug and have a test for it and stuff as part of developing the feature. So in some sense, the cost of making sure your feature worked, of not having the bug, should be part of your point estimate for the feature. And if it wasn't, then over time, you'll get better at doing that because next time this happens, you'll be a little more defensive in your programming and you'll write more tests. So over time, your estimate of what it takes to build a feature will naturally come to include the time taken to write really good tests so you're pretty certain that there are no bugs. Of course, reality is not always like that. So we think it's good to get into the habit of not assigning points to bugs because I think it creates a little bit of pressure on you to fix it. But we recognize that bugs require some time to fix, and that's why your estimates of what your velocity is or your estimates of a story difficulty might sometimes diverge from real difficulty. That's fine. That's it's a learning process, and we all get better at this over time. GitHub has a lot of different integrations with Tracker. Some of them are already described in the how to set up your project. But one of the integrations is that if you annotate your commit message in GitHub with the Tracker story number in a particular format, then when you do that commit, or when that commit gets pushed back to GitHub, it marks the Tracker story as officially delivered. Use at your own risk. Some people have asked, well, can we just use GitHub issues because it might be easier for the customer? You're not going to expose your customer to using Pivotal Tracker. Again, some projects run on GitHub issues or GitHub projects. One of the reasons we use Tracker is of the various systems for doing effort estimation, it's one of very few that actually lets you associate effort with stories, and it helps you track over time how good your estimates are. We believe that's a really, really important skill to develop, and GitHub Issues doesn't give you that. GitHub Issues is like a to-do list. You can rank whether the issue is severe or kind of severe or can wait until you wash your dog, but it doesn't give you any machinery to make an estimate of fixing effort and then come back to what that estimate is. And as far as easier for your customer, most of you have customers that are not very technical. They're just going to tell you what the bug is. They're not any more likely to use GitHub Issues than they are to use Pivotal Tracker. Some organizations that manage really big projects have a whole separate system. Bugzilla is one of the better known open source ones. And all it does is bug tracking. And bugs have life cycles, and there's a lot of reporting about where the bug came from and stuff. You may very well find yourself in an organization that does something like that. But again, for the purposes of this class and the scope of these projects, we've found that Tracker works quite well, and it's a tool that you're already using. So in general, we always advocate for using the simplest tool that actually works for your project. And in this case, the simplest tool is one you're already using. So that's our view. So what that all means is if you wish to use a different way to track bugs or collect them, you can. But we don't think that it adds a tremendous amount of value. And now there's 2 places that you have to look for what your team needs to be working on instead of looking in one place. OK, so that's the report step. That's just R1 of the 5 Rs, I guess. Reclassify. So sometimes a bug may be found in a version of the software that's about to become obsolete, or maybe the bug has been fixed, but the fix hasn't been rolled out to production. So sometimes it's reclassified as no longer a bug, or it won't be fixed. Maybe the bug is part of a feature of the software, and that feature is being revamped or eliminated, so the implementation that led to that bug is actually just going to be taken out of the code base. But assuming that it's a legitimate bug and it has to be fixed, the next step, and possibly the most important, is what is the simplest possible test you can write that shows the bug in action? Like, how tight of a net can you draw around the bug? What's the minimum set of preconditions? So, if you're talking about an RSpec test, that's a short before block. If you're talking about a cucumber scenario, it's how many background or given steps before the actual stimulus that makes the bug happen. But basically, how tightly can you circumscribe it? And by the way, if it's hard to circumscribe the bug, right, if the bug requires setting up a lot of background or given steps just to get to the point where you can trigger it, that's telling you something about your code base too, right? If you can pull out that part of the code into maybe its own method and find a way to separately test that method and then call it, we're going to talk a lot more about this after spring break when we talk about refactoring. But basically, whenever part of your code is hard to test, including a bug test, it's telling you something about your code. So now you have a clean definition of repair, because you have a test that fails in the way you expect when the bug is present. And now you change the code, and the test now passes. Right? So basically, this is the one thing that, as I said, all of these different companies have in common. There's no bug fix without a test. If you didn't see a regression test that reproduces the bug deterministically, then the bug sort of doesn't really exist. And if it's a bug that happens non-deterministically, then that's a real challenge. Right? You're going to spend some time doing that. And then finally, release, which depending on your team's discipline could mean that it's pushed to production, it's pushed to your repo, but it's not in production. It could mean that it's deployed to production. But basically, some guarantee that the fix has now made it into the mainline code. It's made it to master, and if it's not deployed, then it soon will be, because it's always safe to deploy from master. How does this interact with having a release strategy? Well, one of the reasons that some people promote having release branches as well as feature branches is that it gives you a way to deal with bugs a little bit more cleanly. So for example, if you didn't have release branches, you might just say, OK, here's a point at which the head of master was at commit A. We're going to deploy from that commit. Right? That's the kind of standard strategy of deploy from master. But a different strategy is right before you do any release, you create a branch for that release. So here's commit B, which is really just a branch point off of commit A. So it's the same state of the code. You deploy from branch B. And yes, there is a command that tells Heroku, I want to deploy, but don't deploy from the master branch. Instead, deploy from this other branch, the release branch. So now, what happens if at some point you find a bug in the production code? There's a couple of choices that you have. First of all, you can find a bug in the production code, and you can sort of fix it along the release branch, because it's possible that in the meantime, master has changed out from under it in a way that makes the fix not necessarily apply. So I could fix the bug that was found. I could fix it in some other commit, and then I could do a merge from that commit back up to master to integrate a very small fix. That's called cherry picking. And there's actually a command called git cherry pick, which says from this commit point, pick only a specific commit or set of commits and selectively, sort of surgically, merge them back into the main line of development. So this is kind of like fix the bug here and then apply that patch back into the master branch as soon as possible. So you still have your release branch, and now you can do another release from the same branch. Oops, there we go. You can also, some people also call this a crisscross merge, because you had a bug fix that you applied here, and you, besides applying the bug fix in the release environment, you also cherry pick the bug fix back into master, even though you know that sometime later you're going to be doing another branch off of master so that you can do another release from there. The pure branch per release strategy would actually mean that you might fix a bug here and you might cherry pick it, but as soon as you're ready to do another full release, you actually just let this branch completely die. And then you create a brand new branch at the new release point, and you do your next release off of there. So a release branch, sort of by definition, is not intended to ever really be merged back into master. But if you very specifically apply a targeted, urgent bug fix, right? Because if you're applying the bug fix to the release branch, it's probably because the bug is a showstopper. It's something really, really bad. And you may surgically choose to integrate just the commits associated with the bug fix back into master. That would be a cherry pick or a crisscross merge. So whether you use release branches is kind of up to you. I tend to think that if you're doing a good job at stewarding your master branch, you don't really need release branches, but they do give you one additional level of security, because you know you can always temporarily switch to the release branch, do something there, and you're safe to deploy from there.
All right, so that's about bug fixes. Pretty much just follow the same procedure as new feature. So yeah, not really something special here. Unless you're not doing Agile, and then if you're just following some other procedures, then it sometimes makes sense to have special treatment for bug fixes. All right, next will be our last video for the day.
We're going to wrap up talking about primarily how to do this project management from the plan and document perspective. In the surveys, you guys said it was educational to see this alternative universe and why. It helps explain what Agile is, and Armando and I agree with that. Us writing that up helped us understand why the ideas in Agile. Well, one of the big ideas that come with plan and document methods is design reviews and code reviews. So what are they? A design review is simply, once you have the design phase done, you can think of the waterfall model with that architecture design phase. Once that's done, before you write code, you have the design itself reviewed, and the idea is to learn from the experience of people who've done more work than you, and you bring them to the review and they give you feedback. Once you've got a design reviewed and you've implemented it, then you would do a code review, and once again, they would be looking at your code and be able to do that. So the agenda might start like this. If you're going to do one of these, and many companies do require design reviews and code reviews, including Google, that you'd start off with prepared a list of questions and the issues you'd like to be discussed at the meeting. You start off with this high-level description of what it's like, and particularly what the customer wants. Then you're going to, because you've already done an architecture, you'll show the architecture by highlighting the APIs and the design patterns. And as Armando has hinted, we're going to do a lot of design patterns in a couple of lectures. At each level of abstraction, that makes it easier to follow. And then you go through everything. You go through the code, the documentation, the project plan, the schedule, the testing plan, what's called V&V for verification and validation of the project. And the reason you go through everything in this plan and document model is the experienced people are looking at what you've done, like the schedule and the risk in the schedule, and give you feedback. Well, I think that you'll never get that done in time. You should take this approach. So the idea is to take advantage of that. But fundamentally, what a design review and a code review is a meeting. You are going to spend a lot of your time after you leave Berkeley in bad meetings. Meetings that the person who organizes it just doesn't seem to know what they're doing, and they go on endlessly. It's kind of like faculty meetings. Faculty meetings are kind of the worst. It's the curse of getting a PhD. You have to go to faculty meetings. They just talk and talk and talk. Nothing gets resolved, and you go into the next thing. So you are going to learn right now how to have great meetings. And great meetings, and we even give you a handy-dandy 7-letter acronym, which is samosas. Everybody, how can you not like samosas? All right. So if you actually, when you get to these companies, you'll go with it. The HR sources have done it. They put signs in the rooms. They put signs in the meeting rooms of the advice, whether it's Intel and NVIDIA, to try and have good meetings to do that. So the first letter, S, is for starting and stopping promptly. So here when we have meetings at Berkeley, there's this idea of Berkeley time, 10 minutes after our hour. At Harvard, where I was just visiting, there's Harvard time, which is 7 minutes after the hour. So when you say 10 o'clock, it's 10, 10:07. So pick a number like 10:09, right? There's no argument what time 10:09 is. 10:09 is 10:09. It's not rounded up from there. And that's what happens in the Scrum model, right? The Scrum model is you pick an exact time, everybody shows up the same day at that time, and you have a short stand-up meeting. Well, for sit-down meetings, you still want to have a sharp starting time so nobody wastes their time getting there. The A part of samosas is an agenda. You should have an agenda, what the meeting is about, and send that out in advance. It lets people, attending the meeting figure out what is supposed to be there and bring up new things if they're not. And if nobody sends out an agenda, you should cancel the meeting. Everybody's busy, they got things to do. If there's no agenda, you don't get together just to have free coffee, you cancel the meeting. So agenda is next. You need somebody to be taking minutes at the meeting. Well, the minutes will play a couple of rows, but if somebody's not there, they'd like to see what happened, the discussions happen, and it also records what you're supposed to do at the meeting. So that's SAM, or as far as SAM so far. Alas, one of the characteristics of our field, there's many positive characteristics. We work together, we do open source, we share what we do, we cooperate. One thing we don't do so well is speak and let the other person finish talking. We have something of the culture of waiting for somebody to take a short breath and then jumping in and start getting your words in. So that's not good manners, right? Miss Manners would tell you what you do is you let somebody finish their thought. And you don't speak over them. Let them complete what they're saying, then you go on to the next thing. So one speaker at a time. Send the material in advance. You can read a lot faster than somebody can talk. So you'll get a lot more meeting value out of meetings if you send things in advance. If somebody, a paper that you want people to read, you'd like them to actually look at the PowerPoint slides before they get there. And if everybody takes 15 minutes before you get there, the meeting will work a lot better. So we're Samos so far. Action items at the end of meetings. As far as I know, this came from Intel. That's where I first heard the word action items. Maybe it goes back before that. But at the end of the meeting, unlike a faculty meeting, there's supposed to be some actions as a result of the discussions at the meeting. And so the action items are written down at the end of who's supposed to do what as a result of being discussed. Then the last, so now we're to samosas. The last S is setting the time and date of the next meeting. Maybe it's a regular weekly meeting, but even with the regular weekly meetings that we have, sometimes people out of time, you cancel it. But figure out when the next meeting is, and then you're not all done, because what you want is to go over the minutes and make sure all the action items are in the minutes to remind everybody as a result of this, Armando's supposed to do this, Dave's supposed to do that. And so everybody knows what they're supposed to do. And then to make this work, to really have good meetings, you have to hold people accountable, which that means the next meeting, the first thing you do is you go over the minutes where you read the action items. Armando, you were supposed to do this, Dave, you're supposed to do that. So this kind of embarrassment to get people to do what they promise is a way to make people feel good about meetings because work actually gets done rather than you just have these conversations and nothing, you have the same conversations over and over again. So okay, so now you know the secret to have good meetings. You now, with the 2 minutes of instruction, will be able to have great meetings all the rest of your career. So, okay. Now, when reading about design reviews, these are big things for a lot of companies because software projects are always late and they always over budget. So the project reviews have been there for a big part of what's going on. And so this guy Shalloway says, although they're a big part of companies, they often don't work. And so he recommends instead smaller things like smaller groups of people to get the effect of those design reviews and more informal thing rather than this big intimidating organization where maybe a room full of people like this are giving you feedback on what you're doing. And these informal approach reviews might make them more effective, or do mini reviews. So don't do these big, giant processes. Okay. Now, it is what we said, one of the things that was the hope of turning software engineering to civil engineering is these kind of design review things are expensive and time consuming. Wouldn't it be great if there was something that could replace design reviews and projects would still be on time and on budget? So a big thing that was being investigated in software engineering is, can't we find metrics of projects? Can't we measure things about projects so we can tell if a project is doing well or not? And so a lot of investigations of all kinds of metrics. So lines of code, thousands of lines of code, or clocks, right? Effort in person months. How many milestones have you fulfilled? How many test cases have you completed? Or another popular thing is the rate that you're discovering bugs and the rate that you're repairing bugs. These are all things that have been tried to try and make software engineering, software production more predictable. Let's try these metrics. So more or less, and you won't have to have these expensive reviews. And basically, quoting Somerville, who's written a text in software engineering, he says, look, boy, this doesn't work, basically. It would be great if these metrics would work and predict and give you the feedback you need, but sorry, not only does it not work now, there's no signs that it's going to work. So we really need to be open to reviews. So I was talking about plan and document methods. What about Agile in reviews? Well, basically, Pivotal Labs, what we said in pair programming, this is what Kent Beck, right, extreme programming, he says, if code reviews are a good idea, we'll do code reviews all the time with a pair of people looking over each shoulder. So they don't do any special reviews because they always do pair review, and that gets the benefits. GitHub has this other idea they call pull requests instead of reviews. And here's the idea. The developer is doing the code and then releases the code in the main database. Everybody who's involved in the project does this pull request and takes a look then, and this could happen multiple times a day, to see if the committed code might affect their code. And if so, then they're supposed to raise it as an online discussion as part of this pull request. And so basically, because people are doing these, as Armando said, doing these code reviews all the time, this kind of pull requests happening all the time, every day, and so there's mini reviews doing continuously. So once again, another Agile organization really doesn't do special reviews. They just do this pull request. So that's how that fits in.
Right, so that was our last video. Today is pretty compact, so although there are some other stuff I want to comment on, but I'll just skip it. Okay, so quickly, homework. Oh man. Okay, homework. For this week, for the basic options, they'll write a summary about Chapter 10, which is basically Agile team and the workflow. And for the bonus option, do the hands-on for Agile iteration. So on Thursday, the recording, I will show a demo of how to set it up. But basically, it's a similar process. Go to the link, fork it, clone it, go through the setup, basically install dependencies, get the Ruby on the right version, and all that kind of stuff. And then go through the instructions and then see the task. But we'll get there on Thursday. Okay, yeah, so we are running out of time, so that will be it for today. For Thursday, again, there will be no live stream. I'll record it, and then you can take your time to watch the recording. But do make sure to watch it before next week, the first lecture next week, because the recording will be about the part one for what's that? Design Planner. And next week we'll continue and talk about part 2 of Design Planner. So just make sure you watch that before before next week, so that you will be on track, so that you won't be lost when we kind of cut in the middle when we start talking about the second part of Design Planner. All right, so that's it for today. We finished our discussion on the Agile team, how a team generally runs, and how the procedure generally looks like. There are different variations, but I do encourage you, when you get the chance, to at least try out what we talked about in today's lecture. All right, so that will be it. I'll see you next week. Bye.